Okay, finally we'll talk about the protein A chromatography methods. So, among different affinity chromatography methods that are out there, okay, one of the most the chromatography method that's used most in the biopharmaceutical manufacturing industry is called protein A chromatography method. The reason is a lot of pharmaceutical companies are manufacturing the products that are made up with antibody molecules. So many of the APIs are made up with immunoglobulins or antibody molecules. Immunoglobulins are different names for antibody molecules. Especially human antibody molecules are what they are manufacturing. Okay, so if you want to capture your antibody molecule, human antibody molecule, what would be the best affinity chromatography resin? That's the question, right? So in order for us to understand that, we need to study a little bit about these immunoglobulins or antibody molecules. So again, antibody molecules are the proteins that are made by your immune cells, like B cells and T cells, right? And your body's immune system has a bunch of antibody molecules, like millions of different antibody molecules that are being synthesized by your immune cells. And their main function is what? They interact with antigens or infectious agents that are coming in, like viruses or bacterial cells. Okay, they bind to them, and then once they bind, that can attract the immune cells to attack those pathogens coming in. Okay, so they will neutralize and then they will attack and they will get rid of those. So that's the function of the antibody molecules. Okay, so your drug molecules can use those antibodies. For example, if you're using antibody molecules to fight off the cancer, okay, instead of using chemotherapy drugs that are very toxic, you can use these antibody molecules that can bind on the certain cancer cell proteins. Okay, once these antibody molecules bind on the cancer cell, what happens? Then your immune system will fight up. They will kill the cancer cells. Okay, so using your body's immune cells, you can get rid of cancer cells. Those are smart cancer drugs that are used these days. Okay, so a lot of anti-cancer drugs are made up with these antibody molecules. Okay, so that's why antibody molecules are very important these days. So antibody molecules or immunoglobulins come in different families. G, M, A, E, D families. And what's the difference? They have different sequences in the amino acid. So typically antibodies are made up with 4 polypeptide chains. 2 are heavy chains, long polypeptide chains. 2 are light chains that are short polypeptide chains. Okay, so 2 long chains, heavy chains, and 2 short light chains are making up a single immunoglobulin protein. And then the ones that belong to the same family have a similar amino acid sequences, but across the different families, their sequences are a little different. And then their functions in the immune systems are a little different as well. But one of the popular immunoglobulins is immunoglobulin G, which will fight against the pathogens. Okay. So it is known that some bacterial proteins, like have a special protein that are binding on human antibodies, especially this area called Fc fraction. Okay, so some bacterial proteins called protein A and protein B, they can bind on that part. Okay, so protein G or protein A, they are naturally happening bacterial protein. For example, protein A and G are made from Staphylococcus aureus or Streptococcus. Okay, and those proteins somehow bind on the Fc portion of the human antibody molecules. For example, if it's a protein A, this protein has about 40 to 60 kilodalton size. Okay, and they are originally found from bacterial cell called Staphylococcus aureus, and it has a high affinity with human antibody IgG, G1, and G2, as well as some mouse antibody as well. Okay, so especially the binding happens the Fc portion of the antibody. Fc portion is again this area. Okay, so that's a strong affinity. So if you can somehow put this protein A in your resin, yes, it can bind with the human antibody molecules. So that's why companies are using protein A column a lot. Okay. Another example is protein G, originally found from bacterial cell called streptococci. Okay. They also bind with the Fc portion of the antibody molecules. So you can use protein G resin instead of protein A if you want to. Okay. So anyway, so you probably remember the downstream purification platform I showed you in the beginning. Let's go back. Where was that? Right here. See, protein A chromatography beginning, okay, and then cation, anion. That's it. So protein A, they use it first because what? It can remove a whole bunch of proteins that you don't want. It can only fish out the protein you want. So that's the capture chromatography. Okay, and then purify. If there are still other proteins you don't want, get rid of those. Polishing is whatever the small amount of isoforms that are there, you can get rid of it by using 3 different chromatography methods. But the major chromatography that removes most of unwanted protein, the major chromatography that captures your target only is this one, protein A. Okay, so that's why affinity chromatography method is very important. Okay, so protein A, we talked about it. So where was I? So right here, protein A or G, and this is a chromatogram of maybe the protein A chromatography. So see its affinity. There are a whole bunch of peaks together, come together, and one single protein eluted at the end. Okay, so look at it. So recombinant fat fraction from E. coli is a sample. The medium is protein G resin. Okay, and then you use that flow rate 0.2 ml per minute. Binding buffer is a 0.15 mole sodium chloride, and sodium phosphate at pH 7, EDTA a little bit. That's a binding buffer, and the elution buffer was ammonium acetate at pH 3. So they dropped down the pH from 7 to 3. And that's how they eluted. Washing is done at even lower pH with some acetic acid. Okay, so anyway, they were able to capture the target protein. Okay, so that's the end. Okay,